electric crane, and it is used in construction sites where to get things to higher places, like on buildings. So now I'll show you how it works.
No, we didn't really get the purpose of it. It's two-line purpose, really.
So in construction sites, they use cranes to grab up things and place it on buildings where they can build it. They can build another story or something else.
Okay, but they move the loads also on ground also. They can move
Yeah,
loads,
they can
not
use
just...
on that also. So they don't have to pick it up by hand. They use this.
Which they cannot anyways.
Exactly.
So what would be the real purpose?
To shift things from one place to another.
Now where you shift it probably depends on the design also. A crane might not be able to put it up, but maybe just move it on the ground. Who knows?
Yeah.
Just saying. Yeah. The real purpose is to lift heavy loads and shift it.
So now I'll show you how it works. So this DPDT will do nothing. Cut.
What?
Cut.
What cut?
I said that cut.
No. Okay. Yeah.
So this switch makes it go up and the other switch makes it go down. Well, it's not working right now.
And then other things?
Then this makes the arm extend and also come back like this. It's extending and to bring it back. Extending, bring it back. Extending.
You're really proud of it, aren't you?
know.
Yeah.
And then this, yeah, this one. Yeah, this one makes this go up and down. It's just this is going down and up, down, up. And now this, I have made a regulator here. So this is a resistor, this is a resistor, and this is nothing. So basically, right now I can change the speed of the turning of the base. So right now it's on full speed and it will go like this. If I turn it down one notch and move this over here, it will go slower. Wait. It will go slower, as you can see. And if I do the other, it should go slower, but actually the
Can you show the regulator thoda aise karke?
This is how the regulator works. So basically, it connects the whole circuit. So this circuit is connected then, and then it works. It should work very slow right now, but the thing is the resistance is too powerful for the whole voltage. So it just cuts off the whole thing.
Cuts off. So let's not say too powerful, let's say too much resistance.
Too much resistance. Okay. So now, how does it work?
I want you guys to stop using the word power liberally. I know what you mean by it, but अपन क्या करते हैं? Power word हर जगह use कर लेते हैं. पानी का तेज प्रेशर है उसको भी पावर बोल दिया, इलेक्ट्रिसिटी ज़्यादा है उसको भी पावर बोल दिया. ऐसा लिबरली मत यूज करो. सर्च फॉर अ प्रॉपर वर्ड फॉर इट. समझ में सबको आता है क्या कह रहे हो? लेट्स नॉट यूज इट ऐसा केयरलेसली. एवरीथिंग इज नॉट पावर, राइट? ठीक है. ओके. या.
So how does it work? So I'll be dividing this into four motions. One is for this to go up and down, the arm to go up and down. The second is to make the load go up and down. Third is to make the extending arm, and fourth is to turn the whole base. So let's start with the turning of the base. So under this, I have placed a motor right under the base. So I think this would be pretty simple to understand. Is when this motor moves, the base moves with it. Understood? Got it? Now about the regulator I have made.
So when you are pointing that motor out, right motor, Tatish, labeling what you are saying is important. Your words which they are hearing and the visual which they are getting, the visual should match at the same time always.
Okay. Okay. So when the motor moves, the base moves with it because it's stuck. Now, I have made the regulator as
Who's gonna make sure that they actually understood?
So I asked them just before.
Yeah, but I don't think that everyone understood what he said, Rishit.
Yeah.
Sure.
Exactly.
Fine, go ahead.
So
Sorry.
now how does this regulate? So basically the regulator is one sheet of 10 and 3 more. This one is actually connected to the motor and these are connected to the batteries. Okay? So this is the battery.
Can you use another pen, please?
Okay. Take it. So this is the battery. And this is the regulator. So now what happens is, this is a little longer. So when this sheet of 10 is actually connected to the sheet of 10, or here this goes right underneath. So they actually touch. This one has a resistance of, I think, 25 volts, 25 ohms. That's the unit of resistance. This one has 10 ohms and this one has no resistor at all. This one has no resistor. So what happens is when this is connected to this is one part of the battery and the other connected right to the battery, to the motor. So when this is connected to the 10 ohms battery, 10 ohms resistor, it will go slower because when the whole circuit is completed, there's a resistor in place. Same if the 25 ohms, same will happen, but it will move slower. But right now we don't have that much output from the battery. And this one will go the fastest because there is no resistor at all and the current will flow properly. Understood? Yeah.
Yes. What does resistor exactly does?
Okay, so what a resistor does is, so this is a resistor, okay? So what a resistor does is, it acts like a, not exactly a barricade, but it acts like a barricade with holes in it. So what happens is, let's take electricity like water. So water is, this is the resistor. It is a barricade with holes in it. So if this is like only for 4 output, it has 4 holes, water is gushing through it, only some will go through, the other will stay. Only some will go through the holes, but the other will stay. Basically that's what resistor does, but for electricity.
So basically it reduces the overall conductivity of the circuit.
Yes.
Rishit, did you understand what he said?
Yes.
Okay.
Now, we move to the second. How?
So this is the base rotation.
Yes, this is the base rotation. Now, about the arm, how it goes up and down. Okay. So, I'll make this bigger again. This is our base. Then this is the arm. And it extends over here. So basically these both are connected but it allows this to go here. So the stick is over here, so it allows it to go freely but it doesn't actually let it come out. You understand that, right? Yeah. So now this part, and there's a motor over here, and this part is connected to this motor, and the rope is wrapped around the motor. So what happens is when the motor turns this way, the rope gets pulled over here as it's wrapped around it and this goes down, so this will go up. You understood that? Yeah. And then if, so this is connected to a DP-DT, so if this goes the other...
Sorry to interrupt, where do you think is the fulcrum?
The fulcrum?
In this?
The fulcrum is this. The stick which is actually connecting it. Wait, okay. The The fulcrum is the point where it goes like this only, right?
Okay.
The fixed point, right? So the fulcrum is in middle. So when this is going down, this goes up. Simple lever action, like in a seesaw. One goes over here, so the other goes up, and vice versa.
So if you are comparing it with the seesaw, the basic lever, that means you can change the length of the arm and everything to maybe manipulate the force you actually need to lift the arm up.
Actually, do not understand.
We'll talk about it. You continue.
Okay. So you understood why how the arm goes up and down? Everybody? Yes. Now we move on to the third one. How does the arm extend? This may be the most complicated one of them all. So I'll make the arm over here. Okay. So this is the arm. Okay?
Let's just say more fun to implement of all, not complicated.
So so this arm is actually 3D. I have made it 3D over here. It's 2D, but inside it I have placed the spring. This is the spring. Okay? And inside there I have put another arm. So the small arm, a little small. And now this arm, through a hole over here, is connected to a motor. So now how does this work? It's connected to here and wraps around. So when this motor goes this direction, it will pull it, right? It will pull it, and then this will go here. Now when I was thinking this, I did not understand if I release this, it won't go back. So that's why I placed the spring over here. So when I start to release it, when I go the other way around, it will slowly come out because of the spring. Understood? Yeah. Got it? Any questions? No. Okay. So now the last one, the fourth. How the load is being picked up and down. Now, I'll make the whole figure. This is the arm, and a rope is going through the whole thing and down. So this is the weight, and this is the hook, and here is a motor. Okay, understood the diagram? So what happens is same thing. If the motor is going this direction, it will pull this, and the load will go up. And if the motor goes the other way direction, it will release this, and because of the load over here, it will go down. Now, to make this more efficient, I could have made the motor over here. So basically, the thing is, the distance between the force and the fixed point over here, it is more, so it will work more efficiently. So basically, it is.
Did you test it?
Yeah, I have tested it. So, so the total force equals to the distance between this and this into the actual motor force. So the total force on the load will be distance into the force placed by the motor.
Mathematically, it might not be correct. I understand why you are saying that, what you want to say, but mathematically, it might not come out as it is.
Oh.
Yeah, we will talk about it.
Then I may have mixed up.
No, but I understand what you are saying is, so when you say things will become more efficient, that means for the same amount of work, less effort is required.
Yes, exactly.
That is what it means.
Yes, that is what it
ज़्यादा
means.
efficiency का क्या मतलब है कि तुम्हें उतना effort नहीं लगाना पड़ रहा जितना पहले लगाना पड़ रहा था. That is what is more efficient, है ना? Okay, ठीक है. Yeah.
Any more questions? I think. Now, any more questions upon this?
So again, it would be very good if after explaining the parts, you can make a certain statement which will make them think about this machine in a holistic manner. Part by part तो ठीक है, but in a holistic manner. कि see, now connecting all these functions, what magic this machine can do.
Okay. So
Don't rub. Using this only, because this is the picture you have created in front of them, right? Use this picture. Now you have explained it in parts, right? Use these together to create a holistic image in their head. कि देखो holistically क्या हो रहा है. You have to be quick so that there is no time break, जिससे वो picture fade ना हो, and you have to be very precise enough कि मीनिंग भी समझ में आए उनको और वो पिक्चर क्रिएट हो, एंड शुड नॉट बी लॉन्ग इनफ कि वो मीनिंग फेड होने लगे, कि एक ही चीज में फंस जाए.
Okay.
You understand?
So right now, what if I combine all of these functions? That's what you mean. So the whole function would be. So I'll take this part first. I'll make a base and the motor for the motor input. Okay. Then the second one is for the arm goes up and down. I'll make this again.
It would be better if you connect the picture to the real thing now,
Not
making it again. Okay, fine, do whatever you. Yeah, it's fine. मैं भी ज़्यादा interfere कर रहा हूँ. दिख नहीं रहा है इसमें, थोड़ा सा right पे होके कर सकते.
So this right over here, got it? So this will make this. Now for the arm going extending, that also I'll make over here. So this will extend, it will go up and down, and it will rotate, right? Yeah. And then for last but not the least, I make a motor another over here. This connects over here, and this is the load. So that is what I made over here.
Yeah, but you're still not coming to the magic part of it. Look, when combined together, what it can do.
Okay. So now when it's combined together, so this is as you saw over here, this connected to this. Then one motor here,
right in front of the diagram.
And one more motor over here. So now what it can do? It can get this load up.
Now show it with the real machine. Even if not, तुम्हें circuit switch on करने की जरूरत नहीं है. But show it from the real machine. Na, that is the best way. Think about it.
So now this can go up and down. Okay. This load can go up and down. This the arm can extend and come out, and the whole base can rotate. So it can efficiently move a thing to another place. Any questions?
I have one. Anybody has any questions on this? Properly समझ में आया? तुम्हें आया ना? Sure. हाँ, किसको question? Why are you doing this? Any questions? किसी को कुछ पूछना है? पूछना पड़ेगा, सोचो. मेरे पास एक question है, वही lever से related. The second part.
Second part.
Yeah, the second part. So this arm is going up. Here is the fulcrum.
Yeah.
And it is going like this, right?
Yes.
Because यहाँ पे effort लग रहा है. It's literally a seesaw.
Exactly.
So one effort is over here, and your load is over here.
Yes.
It's like one person is sitting over here, the other person is sitting over here.
Yes.
ऐसा हो गया है ना? तो यहाँ पे तुम मोटर से force ऐसा लगा रहे हो. This is the fulcrum, and it is going like this, right?
Yes.
What can you do to lift this load, this arms and ये वाला, with lesser force over here? How to manipulate this lever? Less effort, कम effort के साथ I want to move this arm up.
Well, I think this will answer it. Basically, I could reduce the friction over here so it would go easier and less force would be required, or something else.
Yeah, you can you can play around with effort arm and load arm. The load arm is the one from the fulcrum to the load.
Yes.
And effort arm is from the effort to the load.
Yes.
If you understand how it works, you can manipulate the lengths of those arms to reduce the force at the other end.
Yes. Okay. So now another thing, as I think I mentioned it over here, the more distance between the fixed point, the less effort will be needed. So if I extend this whole thing over here, like this is extended over here, okay, and there's a motor here. You may have to imagine it, or
this will be effort arm.
This will still be the effort arm, but it will just be extended. So as I told over here, the more distance between the fixed point and the load and the effort, the more easier it will be to pick up the load. So if I extend this over here and place the motor over here, it will be easier to make this.
समझ में आ रहा है कि मैं वो क्या बोल रहा है? Okay.
If you have ever seen a seesaw, if this is a seesaw, this, okay? If one person sits over here and the other person sits over here, no, even if this person is weighing more than him, this will still go down. Like if there's not so much difference, but still, like if this guy is 1 kg more, this guy will still be able to push him up because of the distance between the fixed point.
Distance between the fixed point and the guy who is putting the effort.
Yes, that's the effort and this is the load.
Okay. किसी को पूछना है कुछ guys? उसने इतना कुछ explain किया, you guys have no questions at all. So much.
I explained good.
Yeah, that's why there should be questions.
No.
Yes. The more you explain, the more curiosity people should have, because now deeper knowledge they have of it. So it should bring in more questions.
But I have already
It's not the
answered
other way around.
questions.
You did not answer the lever thing of yourself. Okay.
No more questions.
Rishabh. No, this is good. This is good. कोई problem नहीं है. The regulator thing is also fine. But then, if I want to have तुमने तो 3 steps लिए हैं regulator में.
Yes.
1, 2, 3 like that, right? But I want to have more sensitivity. मतलब मैं उस पर ऐसा घुमाता जाऊँ धीरे धीरे, उसके हिसाब से स्पीड धीरे धीरे तेज हो और धीरे धीरे कम हो. Because usually there are no steps. There is a what do you call it? You know, continuous reduction or increment. It's not in steps. You know, तो वो कैसे करेंगे?
I think, but this also in steps only. Like this is connected here. I can just do make it go like this.
No, it's not just about rotating. I'm saying it shouldn't be in like level 1, level 2, level 3. It should be level 1 से धीरे 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 level 10 तक जा रहा है. You should be more sensitive.
So I think to answer your question, I could reduce the distance between the two tin sheets and make more.
It will still jerk out ना. वो फिर भी jerk out होगा. ऐसा पहले suppose maximum resistance पे है तो बहुत ही slow है. जैसे ही higher resistance पे गया एकदम धक्का लगेगा उसको. वो धक्का नहीं चाहिए. It should be much smoother.
Yeah, exactly. So like I just made 25 ohm to 10 ohm. I can put it 24 ohm, 23 ohm, 22 ohm, and that will reduce it slowly.
Basically, more number of closely spaced steps.
Exactly.
Closely spaced, more number of steps.
Yes.
Rather than more highly spaced, less number of steps.
Yes.
Okay. Might work. Okay. Fine. Anything, guys?
No, sir.
कुछ भी नहीं पूछना.
Thank you.
That you have to do again. आया नहीं वो video.
Thank you.
Again.
नहीं.